Okay, here we go. Last video for this set of notes. We are on part 4 for the big ideas and check your understanding. So this is about the 4-step process. So I went ahead and wrote out the 4 steps. In general, you have to state, plan, do, conclude. So state requires that you actually state what the parameter is in context and the confidence level. Then you need to plan. You need to state your name of procedure and your conditions. So far, we only know the name of one procedure. We've only done one procedure. So make sure that you recognize that. It's the one sample Z interval for P. That's the only one we know so far. And then those 3 conditions that we stated in the last big ideas. Then do is to write the general formulas and the specific formulas. And then plug in your numbers and then find the final interval. All 4 of those are required, especially if you want partial credit. And then conclude. So you interpret in context the way we've done several times now. Okay, so that's just a summary of what we did on the previous page. Let's look at something new. The last bit of information from this chapter is about being able to choose the sample size, right? So far, we've just been given situations where they tell us what the sample size is, but a lot of times before you do the survey, you want to choose a reasonable sample size. If you make it really, really large, that could be expensive. So you want to know what's a reasonable sample size without costing too much. Okay, so to do that, we have our margin of error formula here. Remember, E stands for margin of error. It's the critical value, Z star, times the standard error, the square root of P hat times Q hat divided by N. Okay, in order to find a good sample size, you have to plug in everything else but N and then solve for N. So you'll need to know the margin of error, know the critical value, and then have at least an estimate for the sample proportion you think. And then you'll solve with those values for N. 2 things to keep in mind: you will always round up. And if you don't have a P hat, right, if you don't have an idea of what the sample proportion will be, because remember, this is before we take the survey, you can use 0.5. That will give you the widest or the largest margin of error. I shouldn't say margin of error. The largest sample size. It'll be the safest estimation you can make. Okay, so let's see what this actually looks like in a problem. So your company has received complaints about its customer service, and the managers intend to hire a consultant to carry out a survey of customers. But before contacting the consultant, the company president wants some idea of the sample size that she will be required to pay for. So one value of interest is the proportion P of customers who are satisfied with the company's sample service. Company's customer service. There they go. They told us what our parameter is. Proportion P of customers who are satisfied with the company's customer service. And she decides she wants the estimate, so the interval, to be within 3 percentage points, or 0.03. That is our margin of error. Now, 3 percentage points, we always convert to that decimal. Your book a lot of times will say percentage points. Make sure you convert to a decimal. And at a 95% confidence level. So our C is 95%. Okay, so using a conservative estimate for P hat, how large of a sample is needed? AKA, we don't know what the sample proportion we're expecting is. We're just going to use P hat equals 0.5, like we said above. So let's get started by just writing down our formula. Margin of error is Z star times P hat times Q hat divided by N. Okay, we know the margin of error they want us to use, 0.03. The Z star refers to the confidence level. So for 95%, remember Z star is 1.96. We can look that up in table A or in various places throughout our notes. And then P hat, it's saying a conservative estimate. So that's telling us to use P hat is 0.5. Okay, which means Q hat must be 0.5 as well. So let's plug in, see what that gives us. We have 0.0, I'm going to spread that up just a little bit. Okay, 0.03 for E is equal to 1.96 for the critical value times the square root of 0.5 times 0.5, right? 1 minus 0.5 is still 0.5 divided by N. Okay, now this is the equation that I have to solve for N. So I'm going to start by getting rid of this 1.96 on the outside of the square root. So I'm going to divide both sides by N. I'm sorry, I said n, I meant 1.96. Divide both sides by 1.96. All right, so let's see what that left-hand side is going to be. 0.03 divided by 1.96 is 0.0153. Let's go with that. 0.0153 is equal to, now this 0.5 times 0.5, I think you can multiply out. I would get 0.25 divided by n. Now to continue solving this equation, I have to get rid of the square root. The inverse of a square root is squaring it. So I'm going to square both sides. The square and the square root cancel. Okay, let's see. Now I'm going to go down to this bottom row, this 0.0153 squared. So I'm just going to hit the squared key, and that squares my answer. So I got 2.3428. 2.3428 is equal to, all I have left now is the 0.25 divided by n. Now to solve this, I need to get n to the numerator, so I multiply on both sides by n. But then I don't want this 2.3428 multiplying it, so I would divide both sides by 2.3428. Divide by 2.3428. Let's see, the n's cancel, the 2.3428's cancel. I'm left with n on the left is equal to 0.25. 0.25 divided by that 2.3, actually, I'm just going to go up and select it here, that whole number there, 2.34, whatever. Oh, and you know what I didn't notice? Out here it says e to the negative 4. This isn't 2.34 at all. This is a really small decimal. I should have figured that out earlier. Sorry, guys. This is really 0.0002348. So I'm just going to put e to the negative 4 over here. I'm dividing by that same number. Okay, so n is now equal to, what did I get? 1067.1. But I always round up. So that 0.1, even though normal rounding would be 1067, I really emphasize this, I have to round up to n equals 1068. That is my answer. Okay, so if you thought that was kind of complicated, I feel you. Solving for n is not very fun in this equation, but here is the equation that your book gives you to deal with this. Gross. It's formula 7.3. So it says n is equal to the critical value squared times 0.25 divided by e squared. So actually, I guess it's not too terrible, but it's just one more formula to remember, and I'm not going to ask you to do that. So I'm going to say solve for n. Use the formula if you want. Just make sure you show your work. Okay, so next problem says, in the company's prior year survey, 80% of customers surveyed said they were satisfied. So that gives us some background information to work with. All right, so it says, using this value as a guess for p hat. So we are going to guess that p hat is equal to, not 80%, but 0.8, right? Convert to a proportion. We want to find the sample size, so we know our answer is going to be n equals, needed for a margin of error of at most 3 percentage points. Oop, that tells us E should be 0.03 with 95% confidence. Confidence level of 95% again tells us the Z star is 1.96. So how does this compare? Well, let's find out. All right, so we have E is equal to Z star times the square root of P hat times Q hat divided by N. We fill in. See, E is still equal to 0.03. We still have 1.96 as the critical value, but now we have 0.8 as our P hat, which means Q hat is 0.2 divided by N. Okay, we follow those same steps again. We're going to divide by 1.96 on both sides. Let's make sure I write the number down correctly here. Okay, so I know what 0.03 divided by 1.96 is the same thing as it was above, the 0.0153. Now that is equal to, what's 0.8 times 0.2? Oh, of course, 0.16, should have known that. So that's equal to the square root of 0.16 divided by n. I solve that by squaring both sides. Okay, and I know what this is squared again, so let's just check and make sure we're really clear here. I've got my 0.15 up here. This value is what I'm squaring, And I see that e to the negative fourth. Again, that means I have to move my decimal places 4 places over to the left. So this is really 0.12324. That's probably plenty. Okay. That is equal to 0.16 divided by n. Again, I'm going to multiply by n on both sides and divide by this 0.000234 on both sides. My n's cancel, that number cancels, and I have to take 0.16 divided by all of, I need to put divided by all of that. So notice it's only different from our previous calculation in that we had 0.25 when we used p hat equal to 0.5, and now we have 0.16 when we use p hat equal to 0.8. So this number is going to be smaller. And it is. It's 682.95. So I get n is equal to 682.95. But remember, we always round up, so it should be n is equal to 683. All right. And it asked us to compare with the required sample size from question number 1. So of course, I'm just going to say this is smaller. All right. So what if the company president demands 99% confidence instead of 95% confidence? Would this require a smaller or larger sample size, assuming everything else remains the same? So my first thought is that if I increase the confidence level, then the interval gets bigger. But they're telling me everything else should remain the same. My margin of error is not supposed to get bigger. So in order to be more confident with the same size interval, I'm going to have to increase my sample size. Because remember, increasing sample size reduces that interval, right? So increasing my sample size will counteract increasing my confidence level. All right, so let's write that out. But I can also explain my answer, not just in words, but I can be sure of this by finding my critical value corresponding to 99%. Let's check our table A one more time. If it's 99%, it's a confidence level of 0.99. So my critical value should be 2.575. 2.575. Okay. So I can follow this process one more time. This time I think I'm going to show it to you using the formula from the book. So remember, we're still using a margin of error of 0.03, and we're still guessing that p hat is equal to 0.8. So I'm going to show you that formula in the book, like I said. Oops. So we plug in our critical value and square it, plug in our guess for p hat, which gives us our guess for q hat, and then take our margin of error squared. So this is telling us n is equal to z star squared times p hat times q hat divided by e squared. Okay, so I'm going to do 2.575 squared times 0.8 times 0.2, right? 1 minus 0.8 is 0.2, divided by the margin of error, which is 0.03 squared. Ooh, okay, I'm going to type all of that into my calculator. 2.575 squared times 0.8 times 0.2 divided by, I'm going to put it in parentheses just in case, 0.03 squared. Okay, I get 1178.77. 1178.7, round up. Okay, so again, I want to round to a whole number, and I have to round up, so it's 1,179. All right, which of course, if I compare it to my previous sample size, is much bigger. So we had to have a larger sample size. Will increase our confidence level. All right, so there we go. That is it for confidence intervals for proportions. This covers all of section 7.2, which is, like I said, pretty long. I'm going to make a short video that if you haven't watched yet, you should, on why this lesson is fairly long. All right, that's it.